So today what we're going to do is we're going to begin our number section. During this section, you're going to be working with some of the basic mathematics ideas behind working with numbers. And so since we're just doing basic mathematical ideas, you will not be allowed a calculator for the homework or the assessment. So get used to that. We're going to do these by hand. So what we're going to cover in this section is we're going to be looking at different types of numbers. We're going to be looking at integers, introducing some more work with integers. That means positive as well as negative numbers. We're going to be adding and subtracting and working with fractions by hand. We'll be doing some decimals, etc. So the basic number types, the operations that you're going to be seeing for the rest of your mathematical career. Okay? And we're going to start today with an introduction, talking about some different types of numbers and a few other definitions and ideas that you need to have in order to be able to make numbers work for you. So the first thing we're going to talk about is we're going to talk about something called the natural numbers. So you need to write natural numbers, comma, and the natural numbers are the counting numbers. Now I'm going to tell you that the book has made a huge mistake here. The natural numbers do not include 0. Because if you start counting sheep, for example, what do you start with? 1. You don't start with 0 sheep. You start with 1. The natural or counting numbers are simply the numbers that you would count with. So like you think about counting on your fingers. 1, 2, 3, 4, right? So notice that it has these little dots at the end. That means that it continues on in the same pattern infinitely. So there is no such thing as the largest natural number. It's an infinite set of numbers. There's always one more. So no matter how many you could count for the rest of your life, there's always one more. Okay? But they always start with 1 and then increase by 1. Right? Now notice that the natural numbers do not include any fractions or decimals. It's just the numbers like if you were counting on your fingers. Okay? All right. So that's our first definition for natural numbers. The next definition we want to look at is we want to look at the definition of something called a factor. This is a word that you're going to see a lot, and so you're going to need to know what it means. Okay? The factors of any natural number, and you don't need to write this whole thing. I'm going to underline what I think is most important for you to write, okay? All right? Is any number which divides exactly into it, leaving no remainder. So any number that divides evenly into the number, leaving no remainder. So it has to divide evenly into it. We're going to talk about a lot of examples. Go ahead and write that down. So what we're going to do is we're going to learn how to make a list of the factors. Now, I want it as a list, and you need to understand that factors always come in pairs. You can't divide 10 by 5, right, and get no other number. There's some other number. And we always want to make sure that we're listing every factor. So we always want to make sure we're going in numerical order. Okay? So let's look at a process for listing these. To find all factors of a number. Super easy. We're always going to start in the first place. We're going to divide by 1. Always starts with 1, no matter what, because every number always divides by 1. So let's just get a list going here so we can see an example. Let's say we have the number 12. Okay? So I'm always going to start with 1, and 1 goes into 12 how many times? 12 times. So we always start by dividing by 1. Okay? Now notice I put 2 numbers side by side there because those 2 numbers are a pair of factors. In other words, the only number that would divide by 12, that you could divide 12 by 1 and get is a 12. They go together. Pairs of factors always go together. Second, try 2, then 3, etc. Okay? So we're going to try 2, see if that works, then try 3, then try 4, then try 5, then try 6, But remember, the natural numbers are infinite, so I need a place to stop. Yeah? As long as you do it in numerical order. And remember, we're trying to make you good mathematical thinkers here, so you would always do things in numerical order when you're working with numbers, hopefully. Yes? So in other words, do 1, then 2, then 3, then 4, then 5. Don't jump around, right? Okay? Make a list and do it in numerical order. You can stop when you get to a number that is already on your list. So we always know we can stop when we get to a number that we already have written down on our list. So let's just continue doing 12. After 1, what's the next number after 1? 2. Will 2 divide evenly into 12? Yes. How many times? 6 times. Good. After 2, the next number I'm going to try is 3. 3 goes into 12 how many times? 4. And now I don't need to try 4. Why not? Because it's already on my list. And as long as you go in numerical order, that will always happen. So you'll always know when to stop. Okay? So once you get to a number that's already on your list. So now let's just make a list and write them out in a list. Remember, when you're making a list, it's always separated by, what do you separate a list with? Commas, you betcha. It's a list of any kind of items. It doesn't matter if they're numbers. So your factors are 1, 2, 3, 4, 6, and 12. Notice that I wrote them in numerical order. So the factors of 12 are 1, 2, 3, 4, 6, and 12. That is every number that will divide evenly into 12. It's good? Super easy, yes? All right. So let's do another one. I'm going to write a number, and then I'm going to give you a few minutes to write down the factors of it. Okay? So 16, 1 goes into it 16, 2 goes into it 8, 4 goes into it 4 times. I'm going to tell you that you never repeat a factor. So you just put the 4 on. My next number would be since I'm at 4 and the next number would be a 5, I don't even need to try it. So my list is going to be 1, 2, 4, 8, and 16. So if you get a factor that occurs twice, you only write it 1 time. Okay? Don't put the 4 down twice. Okay? When you're making your list up here, you can put it down twice if you want to. That holds as a placeholder, right? But otherwise, don't worry about it. Okay? So then you try 5, but 5 won't work. Then you try 6, 6 won't go into it. You try 7, would 7 go into it? Nope. You try 8, but I don't need to try 8. Why? It's already on my list. Sorry, I didn't complete it because I was hung up on the 4 thing. So there is your list of factors of 16. Okay, so you just start with 1 and then move on. Okay. So that's how to find all of the factors of a number. Yes? Everything that would possibly divide into it. And there are going to be other times when we want not all of the factors, but we want specific kinds of factors. And so that's what we're going to talk about next. Okay. And once you've written it as a product of factors, it's called factorized. Okay? Now, the next thing we want to talk about is the idea of what are called multiples. Now, be careful and don't get them confused. So the definition is multiples. Okay? A multiple is any natural number obtained by multiplying it by any other natural number. Okay? So you're just going to multiple by multiplying it by any other natural number. Now, with factors, there was a stopping point. Yes? Not everything divides into 16. And we knew to stop. But multiples never stop. Multiples are an infinite set of numbers. So they go on forever. We could continue to multiply forever and ever and ever. So we could multiply by 1, then multiply by 2, then multiply by 3, then multiply by 4, then keep that up until we multiply by 643,932,000. Who cares, right? You just keep on. You could go on forever doing this. So keep in fact the idea that the multiples never stop. So all you're going to do is just multiply them by numbers in turn. So multiply by 1. Again, you always start in order. Then multiply by 2, then multiply by 3, then multiply by 4, etc. Okay? Now, generally, they tell you when to stop. So if I want the first 5 multiples of a number, that means I'm going to multipy it by 1, then what? 2, then 3, then 4, then 5. And that's when I know to stop. If I want the first 5 multiples, I'll multiply it by the numbers 1 through 5. So what if I wanted the first 10 multiples? I would stop at 10. Okay? So usually they'll tell you when to stop because otherwise it gets too difficult. Okay? So let's just look at some multiples of a number. Here they give us, let's go to the exercise set. So look at 5b. We're going to list the first 5 multiples of 5. Okay? So 5 times 1 is 5. 2 times 5 gives us what? 10. 3 times 5 gives us 15. And you don't have to write them out like that. If you can do it in your head, that's perfectly fine. All I want is the list. So if you want to just write 5, 10, 15, what's the next one going to be? 20. Then finally, and I'm going to stop at 25 because that's 5 of them, isn't it? Okay? So you don't have to show me the multiplication, but you do need to make a list of your answers. Okay? If it's an awkward number, you might want to show the multiplication just to make sure, because remember, you're not going to have a calculator to do this, so you might want to write it out just so that you make sure you get the right number. Okay? All right. Now, look at number 7. They want to list the numbers between 50 and 100, which are multiples of both 3 and 5. So, 3 and 5. So I could find that by simply listing the multiples between those and then comparing and seeing which numbers are on the same list, or on the list twice, right? Now, but there's also something I know about that. If it's going to be 5, what do you notice about multiples of 5? They end in either 5 or 0, right? You knew that, yeah? So we're only interested in multiples of 5. So multiples of 5, there are going to be fewer of them, yeah? So we can just compare the multiples of 3 to those multiples of 5 and then work it out. So just start making a list. Find the closest one to 50 and just start making a list of all the multiples, right? And then you can compare them and find those lists. This is a really common exercise where you're going to be listing the multiples that are common to 2 numbers. So you're going to work on that. Okay? So, natural numbers start with what? 1 and then go on forever, right? Factor means any number that divides how? Evenly into another number, right? When we're listing factors, we always start with 1, then 2, then 3. How do I know when to stop? When I get a number that repeats. Exactly. When I get to a number that I already have on my list. Excellent. Good. And then finally, multiples just means multiply by 1 times 2 times 3 times 4 times 5, etc. until you get as many multiples as they tell you to get. So what we're going to do is we're going to go to your book and you're going to open up Snowflake. I don't think I can get the whole thing on here. I'll try to project it, but if I can, that's fine. But if not, you'll just use Snowflake.